All right, in this video, we're going to look at simplifying square roots with fractions. We're going to take several videos to look at this. The ones we're going to look at today are going to have real numbers in the denominator, and also there's only going to be one term in the denominator. So we can change that up and do some other things, and we'll do that in some other videos. All right, so first of all, a definition you need to write on your note paper, the definition of rationalize. Rationalize is basically the mathematical process of removing the radical from the denominator of a fraction. Now that radical, maybe it's a square root, maybe it's a cube root, could be anything. So far in class, we've only done square roots, but I didn't want to put that here just because I want you to know that this process works for all the different radicals, not just for square roots. So if you need to, pause the video for just a second so you can finish writing that down. Okay, so here's our first one. In this case, I have a square root and I have a fraction inside the square root. Well, the first thing I'm going to do is I'm going to split this into two separate square roots. The square root of a fraction is the same thing as a fraction with a square root in the denominator and the numerator. All right, and then I'm going to look at this. Well, square root of 16. That's a perfect square number. I know that one. 4 times 4 is 16, so the square root of 16 is 4. And same thing in the denominator. 25 is a perfect square number. I know that one too. Square root of 25. 5 times 5 is 25. So the square root of 25 is 5. And so that's the final answer, 4 over 5. You'll notice there's no square root in the denominator, so there's nothing left to do. We have completed the simplification. Okay, but look at this one. This one's a little bit different. So I'm going to split it into into two square roots, just like I did before. But neither one of those is perfect square numbers, and neither one of them simplifies. But still, the rule is I have to get that radical out of the denominator. So think about square roots. How many numbers go in your circles in the square roots? Right, 2. So if I can put another square root of 7 down here, now I'll have 2 7s and it'll come outside the square root. I'm choosing multiply because remember when we factor, we write down all the things that multiply together to be that number. So this is the same kind of idea as what we did before. If I multiply the bottom times the square root of 7, I need to multiply the top times the square root of 7 as well. So square root of 7 over square root of 7 is the same thing as 1. That's just a clever way of writing 1. And 1 times anything stays the same. I haven't changed the value of my square root of 5 over 7. I'm just going to change its appearance, but it's still going to have the same value. All right, in the numerator, both of those are inside a square root, so I can multiply them together. 5 times 7 is 35. Okay, now let's look in the denominator. So I've got square root of 7 and square root of 7. Well, anything times itself, that is that thing squared, right? Because I have 2 square root of 7 times square root of 7. That's the square root of 7 squared. And we talked about in a different video that squared and square root are opposites of each other. They cancel each other out. So the square root of 7 squared is just going to be plain 7. Okay, if that's a little bit confusing to you, here's a different way of looking at it. I can say the square root of 7 times the square root of 7 is the square root of 49, right? Because 7 times 7 is 49. And I can factor that. 49 factors into 7 and 7. I have 2 7s. So that comes outside and there's nothing left over on the inside. So whichever way you want to think about it, if I have the square root of a number times exactly the same thing, times the square root of that same number, I get the number as the answer without a square root on it. Because either think about it as the square root canceling out, or think about it as factoring and bringing the 7 outside. Now you might be tempted right here to try to simplify this, right? 7 divides into 35, so you might think you need to simplify your fraction, but you can't do that here. The 35 is inside a square root, and the 7 is outside a square root, so they can't interact together. You can't affect one of them with the other one. The 7 that's outside of the square root cannot in any way do anything to that 35 that's inside the square root. So that turns out to be your final answer, square root of 35 over 7. All right, let's do another one. This one you're going to notice is a little bit different. This one I have 2 square roots already. It's a fraction with 2 square roots in it, so I don't need to split it up. It's already split up. And you'll also notice that this one has a variable. So we're going to see how that variable changes things, if at all. All right, now last time when we had the 5 and the 7, we noticed that nothing factored. So in the denominator here, nothing's going to factor, right? I still have that 7. but in the numerator I have 20. So let's see if we can simplify that 20. Well, 20 divides down to be 4 and 5, and 4 is 2 and 2. Okay, so now think for just a second about what number should go inside the house and what number should go outside. Right, 2 should go outside because there are 2 2's. That's what's going to go in the circle. So when I do that, the numerator now is going to become 2. The 5 stays inside because it's just single. And remember, we talked about in class today, if it'll help you to figure that out, you can cross out the numbers that are not prime, and that might help you keep your thoughts organized. The 2 goes outside and the 5 goes inside, but nothing else, because 5 is the only prime number that's not circled. All right, and we didn't do anything with the denominator yet. Let's put that back. Okay, so our goal is to get rid of this square root in the denominator. So remember we said last time you have to have 2 of them to come outside, right? So I'm going to do the square root of 7m on the top and the bottom. So that gives me 2 7's and 2 m's. So when I look at what's going to come outside, I should have both the 7 and an m, because I had 2 7's and I have 2 m's. And then in the numerator, okay, so think about what we said in the last video. This 7m, I mean not the last video, the last slide. Is this 7m going to affect the 5, or is this 7m going to affect the 2? Okay, so if you thought 5, you were right, because the 5 is inside the square root and the 7 is inside the square root. So those we can multiply together. 5 times 7m, 35m. That stays inside the square root. I only have one of each. And on the outside, I've got this 2, and it just stays on the outside. And then we always want to double check if anything needs to simplify. So the numbers that are on the outside go together, 2 and 7, nothing to simplify there. And 35, well, if I tried to do a factor tree on 35, I just get 1 5 and 1 7, so nothing comes outside. There's just one of each. So my final answer turns out to be this, 2 square root of 35m over 7m. All right, let's look at this one. So this one has got a square root with a fraction in it. It has variables on the top and the bottom, and we might be able to simplify this one a little bit as well, because I can see that both of those numbers are even. So let's start with that, 24 and 30. What will go into both of those? Greatest common factor is 2. Oh, no, it wasn't 2 either. Look, that's still divisible by 3. They were even, that's right, but I actually could have used 6. Now, I don't need to start over. I don't need to erase this and go back and divide by 6. I just look at this and say, hey, I can still divide by 3. And so I just divide again. 3 goes into 12 4 times. 3 goes into 15 5 times. Okay, so now m and y are not the same. I can't cancel anything there. 4 and 5, nothing is common to those except 1, so I can't cancel anything there. So far, that's the simplest I can get it. All right, so now I'm going to split it into 2 fractions. And I'm sorry, I'm going to split it into 2 square roots. And I'm going to look at each one separately, looking at the one in the numerator. All right, well, 4, hey, we had that before. 4 is a perfect square number. So that means a 2 can come outside, but that m has an understood exponent of 1. And we're going to divide that by 2, which it doesn't go in at all. So that means m has to stay inside. That exponent of 1 is too small. And then neither 5 nor y can come outside. Okay, so at this point, have we rationalized? Have we removed the radical from the denominator? Nope. We've done a lot of simplifying, but we still have that radical down there. All right, so let's see what we can do. Let's multiply. All right, remember I need 2 of each thing. So what should I put inside my square root so that I have 2 of each thing ready to multiply? Right, I should put a 5 so I can have 2 5s, and I should put a y. So I can have 2 of those. And I have to do the same thing on the top and the bottom so I don't change the value. Okay, so the 5y. Does the 5y affect the m, or does the 5y affect the 2? All right, if you thought m, you were correct because they're both inside the square root. So I'm going to put 5my. I'm going to choose to put it in alphabetical order. It really doesn't matter. You could do it the opposite way. And then I've got that 2 on the outside. And then in the denominator, I have 2 5s and I have 2 y's. So that is my final answer. 2 and 5 do not simplify. That y, there's nothing out here for the y to simplify with. And remember, these we cannot simplify because this one is inside of a square root and this one is outside of a square root. So they have to kind of leave each other alone. So our final answer is this, 2 square root of 5my over 5y. All right, we've got one more. Let's look at this one. Okay, so this time I've already got it split into 2 square roots, but you know what? Because both of these numbers are inside the square root, we can go ahead and simplify with what we have. So what will go into 40 and 30? Okay, 10. So let's divide both of those by 10. All right, and then how about the W's? Do you guys remember what do we do with our exponents when we're dividing, right? That fraction bar just means dividing. What do we do with our exponents? We subtract. So 5 minus 4 is 1. Okay, so think about this for a second. That W to the first. Does it make sense to put it in the top, or does it make sense to put it in the bottom? Well, on the bottom, there were more W's to start with because the exponent is larger. So when we cancel everything out, the extra W should go down here in the denominator because that's where there were more to start with. Okay, so 4 and 3, that's simplified as far as we can. We've only got one W, nothing left to simplify there. Now let's simplify each square root separately. So square root of 4, we've already done that one a couple times. Square root of 4 is 2. 3 and W don't simplify. There we go. Okay, now, when I multiply, what do I want to have inside the square root so that I can rationalize this? So this denominator will go away. Right, I want a 3 and a W. So I want to have 2 of each. So in the numerator, can I multiply those together? Well, no. The 2 is outside the square root. The 3 is inside the square root. So I just have to write them both down. And in the denominator, okay, look, I've got 2 3's, so 3 can come outside. And I've got 2 W's, so W can come outside. Okay, now look, I've got a 3W here, and I've got a 3W here. Can I cancel out the 3 and the W because they're the same? No, because this one is outside the square root, and this one is inside the square root, so you cannot simplify any further. This is your final answer.